So I have two rays that share the same common endpoint. What do you think that common endpoint is called? Vertex. Exactly. Again, that's nothing that you haven't seen before. You guys all know that a vertex is the common endpoint of an angle? A vertex is the common endpoint of an angle. And the way that we label angles is that we use 3 letters. And you knew that as well. Now, I would call this angle B, A, C. Now, real quick, one thing that's a little bit different than what you've probably seen before. The angle symbol that I use has a little bit of an arc in it. That's how I was taught to do it in geometry some many moons ago. And the reason why that my teacher in geometry said that we do it that way is because as you get into trigonometry, angles will be placed upon what's called the unit circle. And the unit circle, as you draw out portions of it, you'll measure arcs. And we all know that an arc is a portion of the circle. It's like part of the diameter, if you will. You guys, not diameter, excuse me, circumference. Have you heard that before? Just that little arc. Just not politely. Thank you. So that's how I've been taught. Most textbooks just use the less than symbol, and that's why I don't use that also, because it looks just like a less than symbol. When you label angles, your middle letter will always be the vertex. You can label them going either direction.
Cat.
It means the same thing.
Sorry.
You're right.
Your ball.
It means the exact same thing. The only thing that's different is just going a different direction. That comes into play later on when we talk about congruencies, as we start to look at triangles and polynomials and things of that nature. Because we have to know what direction we're moving to show that there's what we call a correspondence to something else. So you can either go from the top down or the down to the top. As long as A is in the middle, that's your vertex. That's where it will always be. Okay? Now, 80% of the time, you're going to use 3 letters for your angles. Every once in a while, you can use just 1 letter. Like, for example, here, I could say that it is angle A, because there's only one angle that has that vertex at A. I cannot do that if that was there. Because how many angles are there now that have that same vertex? 3. There's 3 of them. There's 2 smaller ones and the large one. So that's when I can't use a single letter. So if you want to just continually use 3 letters, that's fine. Okay? The only other part on here is what we call the sides of the angle. The sides of the angle are just the rays that make it up.
Right.
That's super easy. I don't know if they really defined that back in the day for you guys or not. We just talked about it briefly. It comes into play when we talk about angle addition here in a second. So far, so good. And I'm guessing the only thing that was new was that little arc thing that I put in my angle symbol, right? All right. So there's, like I said, only a couple things new. Can I go to another one?
Yeah.
All right.
Right, sir.
Just jump right into it then. Let's talk about angle addition. Angle addition winds up being the exact same thing as segment addition, but with basically 2 changes. One of the changes is that you have more letters, and the other change is that no longer going straight, you're just changing direction as you're walking through it. Okay? So when we define angle addition, we define it as 2 angles, or 2 or more angles can be added together if they share a common side and a vertex. That's why we still define the word sides. Let's zoom over a little bit here. 2 angles with common vertex and a side add to equal larger angle. Really, really easy definition. It's the exact same thing as segment addition. It really is. Now, what's kind of crummy about angle addition is the lettering. It really, that's the only thing that gets messy, because it takes longer to write out, and it's very easy to get lost in your handwriting if you don't write clearly. I figured this out eventually. Okay. So, what are the two smaller angles here that make up the big one? Well, ABD and CBD or DBC, either one is fine. So, like yesterday when we had two small segments here, XY plus YZ equaled XZ, today we'll say that it's going to be angle ABD plus angle DBC equals angle ABC. And that's what I meant by the lettering can get kind of messy. But notice, what's the middle letter for all of them? B, and it's the vertex for all three of them. And if you can keep those things straight together like that, it works out just fine. Okay. Angle addition is adding two or more things together that share a vertex and a side to make a larger angle. Same exact concept as segments, but we're turning.
All right.
He's all for it. Shall we look at a numerical example?
Yes.
Okay. I know it's asking a lot. Sometimes I get a little ahead of myself. I don't want to go too fast. You're all excited. All right. Hey, look! I used the same picture, which means you shouldn't have to redraw it. Every once in a while, I have a decent idea like that. What? Every once in a while? Yeah, doesn't happen very often. What?
Can't you just subtract?
I don't know, can you?
Can I?
Why don't we just start by writing it out long form once or twice so that we don't screw something up later on? Because what's going to happen next after this problem is we're going to throw algebra in it. And the more that we get accustomed to writing out the steps, the easier everything becomes. So again, we just wrote this out. We know that angle ABD
Equals DBC.
we don't know that.
No, I was just kidding.
We know that they add together. Could they equal each other?
What?
They could equal each other. They could equal each other if I did that. You know how segments have tick marks?
Yeah.
Congruent angles have arc marks. We'll get to that later. Okay. What does angle ADB equal?
We're 80.
35.
35. Do I know what DBC is?
No, not yet.
Nope. So I know that I have 35 plus something, and it has to equal.
110.
No, it's only 1 o'clock.
Wow. If you aren't the coolest guy, I know.
Actually, wait.
I'm not,
Oh,
so
yeah.
it's okay. What's the missing angle?
75.
75, exactly.
So you could subtract.
All I was trying to do is get you the, I wanted you to just write it out. What's the next line? Hey, am I going to yell at you if you get to put a degree symbol for an answer? No. Because I'm going to forget it half the time anyway.
Mr. Judkins would be like,
I'm hearing that Judkins is a meanie.
yeah,
He is.
You know what? I look at it this way. If you're mathing right, I'm happy. I will be a stickler I will be a stickler about labeling when we get to surface areas, volumes. I will be upset if you forget to put squared or cubed or something like that. But in the grand scheme of things, if you're doing all the math and you forget a degree symbol, you're mathing just fine. Don't worry about it. So.
Mr. Judkins, you would say 75 of what? He would say that's why you need to put the symbol.
I know. I've been around a little bit longer than him. I've learned to just fight the good fight, and I find that the good fight is not that.
Right. That's how accurate. Me and him argue all the time last year.
Well then, you know what? For you have to put degree symbol so that way I can argue with you. All right?
But then he would try to talk to me and he would admit that he was wrong.
But I won't do that. Are we okay with this? Let's try another one.
Joseph.
Did you just copy? Oh yeah, that was wrong. No, like, I just now noticed. It was like.
What's going on in your mind half the time is what I'm wondering. I've only known you for like a week, but all I know is you're just like, dude.
Been like that my whole life.
All right, same basic principle, ladies and gentlemen. When you have problems like this with the algebra friends, where you have x values, notice it's not only giving you certain specifics, but it's also asking you to find a specific angle. Geometry is like that. It takes algebra and adds one step. Remember, geometry is one step after algebra, so why not just make your life a little bit more annoying by adding one more step to your problems? So, in a case like this, you still do the same scenario. I would really like it that you guys write out what you're going to do before you do it. What's that? I'm just saying, it's just, especially for the first few of these, it will make your life so much easier. Also, notice the information they give you. What do they give you here? The ADC measure. What is the ADC in relation to the diagram?
Oh, the whole thing.
The full thing, exactly. So we know that the two smaller angles have to add up then to equal what? 135. Okay. We don't know that they're equal to each other. We don't know anything like that because it doesn't say that. What we do know, in fact, is that I can put out that statement of angle ADB plus angle BDC has to equal angle ADC. Yes, ma'am?
Where are the x values? I can't see.
Just degree symbols.
Oh.
Yeah, it says 7x degrees.
Oh.
A lot of the textbooks will do that because it's an actual, whatever it winds up being, it's going to be some degree value, but we don't know. Yes, sir.
Since this is very so far.
Now, what you're saying here is that these two are equal to each other. Does it say that in here anywhere? What does it say?
Oh, plus.
Remember, what we know is that these two angles have a common vertex and they have a common side, so we know that we can add them together to equal the 135.
Whoa, pause, wait a minute.
Write it up. But here's the thing, please, write this out.
I am.
Okay, look at this.
No, all right, you're on the right track. What's ADC? What's it say?
Like you have it.
So that's equal to 135.
Yeah.
Well, it said it equal to 135. It said it equal to
So instead of slapping my butt, you slap my feet.
So,
Wait, hard? You slap
basically, it's.
my thigh or something. I don't know. You slap my feet.
Oh, okay, I get it.
That was the idea. Now that's the idea by writing that out because that information is given. A lot of times it might be written in the statement, it might be drawn in the diagram, a little arrow,
Yeah.
but you just gotta read it. It's right there. Write out the statement, fill in the blanks. All right?
This
All right,
wait,
124.
I didn't get that.
No, that's the equal. Yeah, right.
So with any luck, if we're doing this right, we're getting this.
Wait, what was it?
7x plus 11x plus 9 has to equal 135.
Oh, that's where I got it.
Okay? Now you're at a two-step equation where on one side of the equation you have to just combine like terms. 7x and 11x is how much?
So let me just hold on. A, B, C.
Two-step equation. What do I do next? Bless you. Bless you. Very good. Subtract 9.
Alright, so I just want you to casually do this for me because they're going to be spread out.
And now, what's that?
26, so you're lying.
26, right? Yeah. Yeah. Divide it out and you get 7.
What was it?
I figured dumb.
Now remember, it didn't just ask to figure out what x was, it asked to figure out what BDC is. That's this angle here. So if x is 7, you take 11 times 7 and add 9.
Let me second.
77 and 9 is? There you go.
Equals
It is 86.
It is 86, yes. Okay. Remember, guys, the algebra that we're setting up is exactly the same stuff you did with segments. It's the same thing. The only thing you have to worry about is that the lettering gets messy. Okay? Yes, ma'am.
right.
Catch with your shoulders in school.
Now you are.
Catch with your shoulders in school.
Should we do one more?
You're showing your face.
3. Gee, my notes look wrong.
Same exact setup. Write out what you have. Write out the statement for the angle addition. And let's see what we get. Take a minute or so to do so. Yes, I'm even late sometimes. Wow. Are you saying I have dad humor now?
It's become civil war. It's civil war.
It's easier. Just casually. All right. Sex.
Or hot dog. Hot dog. But you know what's the sex hot dog? That's crazy. How old is she? What if you leave from like the other one? My brother, he's like your brother.
See what I'm saying? A lot of every problem is going to have some sort of information for you to finish it. In this case here, it tells you the entire one is 78. So you take those two small chunks each, and that's just one of the things you'll just get used to looking for. It'll tell you what it's going to be. You just got to read it. Geometry is weird. It's a lot more detail involved. That's why we start real slow. So if I start by writing out my statement, I have n RP plus angle PRQ is n RQ. All right. So, I've never had so many never so many kids ever that just want to try to pronounce all these little letters together. And then this year, no one's ever it's gotta be then like last year, nobody did it. For some reason, you guys think it's funny to say you're something. So angle NURP is 8x plus 7.
Ooh, I be doing this, man.
Angle PERC.
Angle PERC.
I'm just trying to act like a doofus, but it's not working. And then angle NRQ, according to the problem, is 78. And now it's a matter of filling in the blanks. So on one side of the equation, we can combine like terms. So we get 8x and 4x is how much? 12x. 7 minus 1 is 12x plus 6 is 78. Oops, sorry, don't know how to write. Two-step equation, what do you do first?
That 6.
Not any other 6, that 6.
Then you're just going to casually divide that 12 by 7.
How does one casually divide? We just kind of stroll. I stroll up to it and say, you know, casually, I'm just going to kind of like relax, just kind of, you know, I'm just going to divide this up now.
6.
So I get 6 by value of x, but is that my answer?
No.
No, what do I have to do?
Plug X, plug
I'm not doing electrical work.
Then take it like
We don't plug in numbers.
Then you
We
paint numbers.
We paint by numbers, we don't paint numbers. We substitute in values.
I always like to plug in my numbers.
Michigan said
So-
plug in the number. That's why I said plug in.
Looking for P, R, Q. All right, real tough now. 6 times 4.
24.
Subtract 1.
23.
There you go. All right. I got 4 problems for you tonight. It's on page 32.
Wait.
These 4. It's on page 32. I want you to do numbers. What is it? 22, 23.
Wait, is this homework?
Yes, sir.
How many questions?
4. You know, I can make it 40 if you want.
Dang. I mean, that's only going to make me smarter.
If you want, I have it up here on the board right now. They are circled. Please, just take a picture of it. Come down here, take a picture of the 4 problems, and start working on said 4 problems. We'll do more of these types of problems tomorrow. Yes, sir. Okay?
No, I was going to grab 20.
No.